Let's talk about building a kernel. So the kernel makefile is pretty nice. It supports parallel builds, multiple jobs, so you can use the -J option to make. I typically put a number twice the number of cores I have. So if I have a 4-core system, I do a J8. So 4 things can be compiling at the same time while 4 things are, say, waiting on the disk. The target BZ image is to make the bootable image. So you can say make BZ image, or of course make -J8 BZ image. For other sorts of platforms, maybe for an embedded device, then the target would be U image. Some cases, maybe it's VM Linux or something else. VM Linux is going to be built when you make BZ image, and it's going to be inside a BZ image in effect. It'll be stripped and compressed and put inside BZ image. So you're going to have both. VM Linux will be in the top level directory and BZ image will be underneath the architecture. After you make the kernel, you typically make modules, and the kernel and modules are the default. So if you just say make -J8, you should get the kernel and the modules. The make module step should build all the things that you selected as an M. So probably lots of them, and there'll be .KOs all spread through the tree. Because there's a lot of these and the sum total of megabytes compiled is probably a lot bigger than the kernel, this step is probably the longest step. It could typically take, several times longer than building the kernel itself. Once you've built modules, then you can install them. So you say make modules_install. Not only does this make a directory underneath the lib modules of the kernel version and copy your .ko files there, make modules install also calls depmod to produce the files for modprobe that are used for dependencies, for example. Now, because you're going to write underneath lib modules and maybe create a new directory or directories, typically you have to be root to do a make modules install. Generally, in the kernel makefile, targets that have install in the name, like modules_install, imply you need to be root to do that part. So you don't need to be root to build a kernel. You don't need to be root to compile modules, but you have to be root to install modules or to install the kernel. And you install the kernel with make install. That should copy your BZ image file into the /boot directory, and it will rename it typically VM linuz-kernel version. And make install should update your bootloader config file if that's required. And it often creates an initial ramfs or initrd image, although it does depend on the distro. Some distros, like Ubuntu, sometimes you got to do this separately. You got to make an init ramfs with a separate command. Another handy option with the makefile from the kernel is make clean, right? So that removes generated files. If you do that at the top, it cleans the whole tree. A handy little tip is you can just do a clean in a subdirectory if you want. So what you do is you do a make -C and then the path to the kernel makefile directory, and you say M equals $PWD, so that's going to be the current directory. And then you say clean. So it would be make -C, maybe // space, M equals $PWD space clean. The clean doesn't remove a .config if you have one, if you do it at the top. But remember, make Mr. Proper does. So make Mr. Proper is a little more brutal than make clean. Another feature of the kernel makefile is you can cross-compile for other architectures. And that's commonly done because Linux runs on lots of different architectures. If you want to cross-compile, you need a cross-compiler. You need a whole cross-development tool chain. You need libraries and the linker and the compiler and so forth. And generally, the tool chain is built with some sort of prefix of the form architecture, and then maybe Linux, and then some other part of the name. So maybe you've installed a cross-compiler for a certain ARM target, and maybe the name for the C compiler is ARM-Linux-GNU EABI-GCC. So then what you need to do to use the kernel makefile for cross-compilation is you need to set the environment variable cross_compile equal to the prefix. And then you can say make arch equals the architecture you want, say ARM, and what you want to make, like uimage. It'll use a cross compiler and it'll make a uimage. In this case, the uimage would be ARM code. So this upcoming process where we're going to build a kernel and modules and install the kernel and install the modules is going to take quite a while. It took me about 40 minutes on a medium speed machine, so it could take you quite a bit longer, maybe a couple hours. If you got a slow machine and you're going to try to follow along, so just be ready. Let's look at making some stuff. Here we are in the top level kernel directory. Let's edit the kernel make file and make a new version. So instead of let's put something new here. Let's say build test. So our kernel is going to be 3.10.0-build test. So we save that make file out, and just so that we have to compile everything, in case I built anything here, we're going to do a make clean. That was really fast on this system. There wasn't much to clean actually. And now let's time making a kernel. Got 4 cores on this little system. So I'm going to do a J8. Oops. And let's see how long that takes, just as an example. There we go. After a little more than 5 minutes of real time, our kernel should be done. Let's look. There's our VM Linux file. Pretty big, 146 meg. Let's look for BZ image. We see x86 boot BZ image and x86 64 boot BZ image. Those are actually the same. One of them is a link. Let's look. We see the one underneath x86 64 is a link to the one underneath x86. And we see the BZ image is like 5 meg, much smaller than the VM Linux one. The VM Linux one has symbol information and it's not compressed and so forth. Let's look at making modules. Get an idea how long that takes on this little box. So there we go. Making modules took over 17 minutes. Okay, so we made modules. Now we need to install the modules, and we need to be root for that. So let's start a root shell, make it a little bit easier. So now we're root. We're in the kernel top level directory still, and we're going to do a make modules underscore install. There we go. The make modules install took 1 minute and 41 seconds or so. Not too bad. Let's go look in the lib modules directory. Here we are in lib modules. We do a long list for time, and we see the top most recent directory there is the 310.0-build test. That's the one we built. Let's pop back. So we're back in the top level kernel directory, and let's time doing a make install, which will install the BZ image file into boot and do a couple other little things. There we go. The make install finished in just over a minute. Let's go to the boot directory, do a list for time. Look at the top. We see we have a new init ramfs for our build test kernel version. That got created when we did the make install, and system.map link changed to be the system map for our kernel. That's symbols and addresses. VM-linuz is a link to our new VM-linuz file, and there's our new VM-linuz file. There we go. That's the stuff that got created when we did our make install. So we configured, built, and installed modules and a kernel.